Hello. Okay, basically this topic electrostatic, right, is the study of electrical charges at rest. So they are stationary. Right, let's imagine if you have 2 point charge placed in space, so this is generally what will happen. Right, that point charge itself would actually give out electric field in a radial format, right? So it's spreading outwards. Now let's say when you place a positive point charge in space, the electric field lines will be drawn this way, alright, spreading outwards, and the field lines will be all pointing out. But when you have a negative point charge, the electrons, right, will actually not in the case of all electrons, sometimes it can be an anion as well, right? But generally saying, when you have a negative point charge, you have this electric field line that is drawn in the same manner as the positive one. However, the electric field lines are all pointing in, right? So this is the drawing of the static charges and their electric field line. Now, take note, whenever there's an interaction between this positive charge and a negative charge, these are unlike charges, and as we know, when we place two unlike charges in space, there will definitely be an electrostatic force of attraction. But where does this electrostatic force of attraction come from, right? Basically, when you place them in space, there will be this continuation of electric field line. This electric field line they give out, there must be a continuation between them, and the electric field lines will interact in such a way that they actually form a closed loop, right? They form a closed loop. So this joining of the electric field lines would explain why there is an electrostatic force of attraction between two unlike charges, okay? And let's say in the case where you have two like charges, right? Two like charges placed right next to each other. So how will the electric field lines interact such that they can reflect, right, the electrostatic force of repulsion between them? So let's have a look. Whenever we have two like charges placing right next to each other, do remember that the electric field lines will never interact, will never touch each other, right? They will go very close, but they will never touch. So this is how we can draw the field lines. Just imagine there's an imaginary line at the center where the electric field lines coming out of these 2 point charges do not interact, right? So there is one good way for you to draw the electric field. Okay. Sorry. This one, it's actually going in, right? There we go. So these are the electric field lines that you draw for two like charges that reflects, alright, a force of repulsion. And do take note, right in the middle there's an empty region of space where there isn't any electric field lines cutting through it. What do we call this point? Right, this point you can mark it with an X, and you can call this the neutral point, right? The neutral point. The neutral point is a point of space, right, where if you place a third electron, right, or if you place a third charge into this region of the space which I drawn with a dashed circle line, right? If you place a point charge in that space, it will not experience any electrostatic force of attraction and repulsion, depending on whether they are like charges or unlike charges, okay? That point charge that you place in this region of space will not experience any electrostatic force. It is what we call a neutral point. Okay, let's move on to the next portion. Okay, when we talk about electrostatic force, we are curious and we want to measure how strong that particular force is as well, right? So generally, right, there's a rule of thumb that we should know, right? The distance between the center of the atoms, or the center of the point charges in this case, is the center of the point charges in this case, alright? The distance between them, if you square it, the magnitude, how strong that force is, right? That magnitude of the electrostatic force is inversely proportional to the square of distance between them, right? The square of distance between them. And where do we measure this d, alright, this spacing between them? It must be measured from the center of the point charge to the second center of the point charge, alright? To the center of the second point charge that you have. So this is the distance d.